Hi, and welcome back to the Implementing and Administering Cisco Solutions CCNA 200-301 video series course by EC Council. My name is Glenn Singh. In this video, we will take a look at comparing IPv6 addresses. So let's dive on in. You may be wondering, what exactly is IPv6? Well, IPv6 is a new generation or the new version of Internet Protocol. Previously, we learned about IP version 4 or IPv4. In this video, you will learn more about IP version 6. So, IPv6 addresses consist of 128 bits in length, unlike IPv4, which is 32 bits. Now with IPv6, we have 128 bits. Therefore, it gives us a lot more addresses to use. IPv6 is written in hexadecimal notation, which means it ranges from between 0 to 9 and after 9, A to F. With IPv6 having 128 bits, this simply allows IPv6 to scale to approximately 1 udecillion addresses, which is technically 10 to the power 36 number of addresses. An IPv6 address is made up of 8 hextets. Each hextet is comprised of 16 bits. Therefore, this means 8 hextets multiplied by 16 bits per hextet will give you the total 128 bits in length for a single IPv6 address. And here you can see the hexadecimal values, which range between 0 to 9, and after 9, there's A to F. So to put simply, each hextet range from between 0000 to all Fs. The default subnet mask for any IPv6 address is /64. So to get a better understanding of IPv6, let's take a look at this address. This address is a global unicast address. So let's break this down a bit further. Well, so far, we know the default subnet mask is /64. So which means this portion of the address is known as the global routing prefix, while the right side is known as the interface ID or the interface identifier. To further break down the IPv6 address, these first 3 hextet actually represents the global routing prefix itself, which is assigned by the provider. This portion here, which is 16 bits, represents the actual subnet itself. The last 64 bits represents the interface ID. This here is an IPv6 written in its full format. However, it is important to know how to shorten this address. So let's take a look at writing a shorter version of this address. Since this 0 here has no value, we can exclude it. Additionally, the letters is not case sensitive, so we could write them in common letters if we please. Since this hextet is filled with zeros, we can insert a single 0 to represent this one hextet. The same can be done for these other hextets as well. And as you recall, this 0 here has no value, so we can exclude it. So now we have a shorter version of the address above. But we can even write this even shorter. So let's write this address in even a shorter version. Notice here that these values are a continuous stream of zeros, Once there's 2 or more hextets filled with zeros, we can use a double colon only once to represent this value. Therefore, we can place a double colon to represent these 3 hextets, which are all zeros. Remember, you can only use a double colon only once, and it must be with a criteria where 2 or more hextet is filled with only zeros. And this value here represents the shortest version of this original address. So now you have learned how to actually shorten an IPv6 address simply by writing it out. One type of IPv6 address is known as the global unicast address. In the IPv4 world, we'll typically call these addresses Internet Assigned Addresses or public addresses. In IPv6, we have a public address as well. These are known as global unicast address. And as you can see, a global unicast address, the first hextet begins with 2000. And the default subnet mask is a /3. Another type of IPv6 address is known as a link local address. The IPv6 link local addresses are in the FE80:10 network block. The link local addresses are used for local communication only. This means there are actually 2 IPv6 addresses on a single interface. One address is a global unicast address for communication outside of the local network or outside of the local IP subnet. The second address is one link local address which is used for local communication. Just as devices uses a MAC address to communicate within their own local area network or within their own subnet, in an IPv6 network, the link local address functions the same exact way. Only communication that is beyond the local network, then it uses the global unicast address to speak outside. The loopback address in IPv6 has the same functionality as a loopback address in the IPv4 address space. However, in the IPv6 space, the loopback address is :1/128. This means only the first bit is 1 in the entire address. Unlike IPv4, the IPv6 loopback address is actually a single address only. Another type of IPv6 address is the unique local. This type of address has the same functionality of a private IPv4 address and is really limited to your network. This address belongs to the FC00:7 network block. Furthermore, there's an Anycast address. This type of address is shared between multiple devices. However, the transmission of a message is sent to the closest device based on the geographic location. In the IPv6 world, there's also multicast transmission. This address is typically used by a group of devices. For assigned addresses, they use a network block of FF0s, :8. For solicited nodes, they use this network block instead. One very important address is known as a modified EU64. This process uses a client's 48-bit Ethernet MAC address and inserts another 16 bits in the middle of the 48-bit MAC address to create a 64-bit interface ID. So you're probably wondering, what is the purpose of this address? Let's imagine that the service provider only gives the first 64-bit of an IP address. Let's say the IP address is 20.123.4:DB8:A:/64. This portion of the address here belongs to the network side. But then this other portion represents all zeros for the interface. So which means that we as a client perhaps need to create the interface portion or the interface ID of this address and attach it to the global unicast portion of the actual IPv6 address. So to do this, we can use the EUI64 process on a router. The router will automate the process for us and it will make the magic happen. So to get a better idea, let us open Cisco Packet Tracer and actually take a look at the configurations. So now that we have Cisco Packet Tracer open, let us click on Network Devices, click on Router, and we can bring up a 2911 router. Simply click on it and then click anywhere in Packet Tracer. Now, let us click on the router itself and click on the CLI tab. As usual, we type no and press enter. Press enter another time and we'll be able to access user exec mode. Next, we can verify the number of interfaces available on this router. We can use the show IP interface brief command. We can see there are 3 available physical interfaces. There's Gigabit Ethernet 0/0, 0/1, and 0/2. So let us first configure an IPv6 address on Gigabit Ethernet 0/1. To do this, we need to go into Global Config. Since we are configuring IPv6, we need to enable IPv6 unicast routing. With IPv6 unicast routing, the router can perform, of course, routing of IPv6 messages. To do this, we can use the IPv6 unicast routing command in global config, like so. Now that we have enabled IPv6 unicast routing, let us head over into Gigabit Ethernet 0/1. By default, there's already a MAC address configured on this interface. We can simply change the MAC address simply for our exercise by using the MAC address command followed by the MAC address we want to insert. So now we have inserted our very own MAC address. Next, let us configure this interface using the EUI64 process. However, we will only provide the first 64 bits of the IPv6 address. To configure an IPv6 address on an interface, we use the command IPv6 space and address. We specify the subnet mask by simply using the prefix length, which is /64. And we can use the EUI-64 command. So now, this address, or this configuration, to put simply, the device should take this MAC address, split it in half, and insert 16 bits between it. So let's actually work out what happened before we actually validate the new address on the interface. Well, first of all, we are using this MAC address. The EUI64 process is going to split this MAC address into two pieces. And in between, right here, it is going to insert an additional 16 bits. Why? Because the MAC address is 48 bits in length, and we need to get it up to 64 bits in length. So we are moving from a 48-bit address to a 64. And the EUI64 process will insert FFFE right between here. So what exactly is going to happen? Well, to put simply, let's take a look at the calculations. So if we convert some of these bits here from hexadecimal, because this here is a MAC address here, we could convert some of these bits from hexadecimal into decimal to take a look at the working. So let's convert this first bit. We'll get 1, 2, 3, 4. So this first hexadecimal value, we get 4 bits. We'll convert this second one, we get another 4 bits. Now the EUI64 also flips the 7-bit from the left. So which means if the bit is a 0, it will flip it to a 1. If it is a 1, it will flip it to a 0. So therefore the EUI64 process will flip this 7-bit. Because it's a 0, it will flip it to a 1. So if we write out the remainder values, we get 0, 0, 1, 0. This one will be 0, 0, 0, 0. Converting this back to hexadecimal, we'll get 0. Converting 0, 0, 1, 0 from binary back to hexadecimal, we'll get 2. Then we can take these two zeros here, bring it down. Then these two ones, we could bring it down here. We could insert the FFFE right there. These other two ones, we'll insert them here. And these twos, we can insert them right here. All we need to do now is to actually insert our periods or our dots where they're supposed to be. So we can insert one here, and I forgot an F actually, so let me fix that. Could insert another dot here. So as you can see, FFFE is actually in the middle of the address. And this here is a very quick indicator how we can identify an address that actually went through the EUI64 address. And this here is a quick indicator how we can identify an address that went through the EUI64 process. So now that we have our address, let us validate if this process actually works as expected. To do this, we can use the show IPv6 interface brief command. And as expected, we have the first portion of the IP address which we had assigned, and we can see here that we have the second portion which we have predicted. Remember, this 0 has no value, so therefore it is excluded. We have 200 dot, well not dot, colon 11ff dot fe11 2222. So just as we have predicted in our calculations, we actually got our address here. Additionally, we can use a show IPv6 interface command as well. So as we can see, we have the global unicast address, the first portion that we had assigned. We have the second portion as well. And we can see right in the middle here, there's FFFE inserted, which is an indication that this has went through the EUI 64 process. Additionally, look at this. There's also a link local address that is assigned. And this link local address always begins with FEAT. And notice carefully that there's FFFE in the middle of this link local address. So which means that even this address has went through the EUI 64 process. Keep in mind that whenever you configure an IPv6 global unicast address, a link local address is automatically assigned. To manually configure IPv6 link local address, we can use the following commands. We begin with the command IPv6 address, then we can specify the actual link local address. Let's say, for example, we are using FEAT:2. Next, we can specify the command link local and hit enter. If we validate our IP address once more, by let's say using the show IPv6 interface gigabit ethernet 0/1 command or the show IPv6 interface brief, we should be able to see this change. And we can see it right here, FEAT:2. So now you have learned how to actually perform the EUI 64 process. You have learned how to configure an IPv6 interface with both a global unicast address and a link local address. So now you have learned how to configure an IPv6 address, both a global unicast address using the EUI 64 process and a link local address. Additionally, these are the configurations that you can make if it is you want to manually configure an IPv6 address without the EUI 64. Furthermore, you will see here how to configure the link local address by using the command IPv6 address followed by the link local address and the link local command at the end of it. Always remember to do a no shutdown to actually enable the interface. This is a very important show command to help validate the changes that you have made and that the interface is actually up, which is the show IPv6 interface followed by the interface ID. You can get the physical status as up. You can get the layer 2 protocol as up as well. You will be able to verify the link local address and you will be able to verify the global unicast address as well. Furthermore, you can use the show IPv6 interface brief command. In this screenshot is showing you how to verify your IPv6 or IPv4 addresses on a Windows computer. You can simply open the command prompt and use the command ipconfig. With this output, we use the command ipconfig /all. This will give us all the details on the interface. Here we can see the IPv4 subnet mask together with its IP address. We have the default gateway and even DNS server configurations. Further, we can see there's IPv6 addresses assigned here as well too. On Linux devices, we can use the if command to verify again IPv4 and IPv6 information. In this video, we discussed the need for IPv6, we covered various types of IPv6 addresses, and we also take a look at configuring IPv6 on a Cisco router. In the next video, we'll be describing various wireless principles. I hope this video has been informative for you, and I hope to see you in the next one.